Mainly, many of you who doesn't know what is the meaning of acids, remember the definition is this: acids are the compounds, definitely they are not elements. They must contain one or more hydrogen atoms. Okay, and when dissolved in water, okay, Dhanesh and Rushi, next time please join on time. Okay, fine. So these are the acids are the compounds which contain one or more hydrogen atoms, and when dissolved in water, they produce hydronium ions, the only positively charged ions. So this is very important. Okay, say for example, you know HCl. When we dissolve it in water, it will form hydronium ion, where water will donate its lone pair to H and forms a coordinate bond, right? And Cl minus. There is no other positive ion in this. But if I take NaHCO3, sodium bicarbonate, when we dissolve it in water, what you are getting here? Na plus. H plus will become H3O plus. Carbonate CO3 minus 2. Now, because you are seeing here hydronium ion, you should not call it as what acid. The reason, it is not the only cation. There is also sodium ion, which is also the positively charged ion. Therefore, this is not an acid. Only positive ion should be hydronium ion. Only such substances we will call as acids. Okay, so you already know lots of acids: H2SO4, sulfuric acid, nitric acid, right? Acetic acid, CH3COOH. Lots of acids we know. Okay, so now we'll go to what are the classifications of acids. So there are different kinds of classification in acids. First one, based on the sources they are obtained from. We have two: organic acids, inorganic acids. Since we have already learned organic chemistry, now we know what do you mean by organic acids, right? These are the, see, all the organic substances, they were obtained earlier from plants and animals. Therefore, the name organic. But now we know we can synthesize all of them in the laboratory. Okay, so organic acids which are obtained usually from plants and animals also, or insects also you can call them, they must contain carbon atom. So what is organic chemistry? Another name is carbon chemistry. So carbon must be present in any organic substance if you have to call it organic. Some examples we can see here: oxalic acid, acetic acid, formic acid. We are familiar with formic acid, acetic acid. Oxalic acid is where COOH twice is there. So when you write its structure, it looks like this: COOH, COOH. But don't worry about the structure. Oxalic acid is actually having two hydrogen in it. It's a dibasic acid. Okay. And most importantly, these are all weak acids. Weak acids are which? The one which will partially ionize. Okay, so the key word for weak is partially ionize, or you can call it as partially dissociate, but in ionic substances. Okay, now partially ionize in water. Say for example, if I take CH3COOH, okay, imagine there are 100 molecules of CH3COOH. You dissolve it in water. What you are getting? CH3COO minus plus H3O plus. But out of 100 molecules, only 5 molecules are ionized. What about 95 remaining molecules? They are unionized. they remain as it is. Therefore, we call acetic acid as a weak acid because it is partially ionizing. Okay, you can say only 5% dissolved in it. Fine. Therefore, these all organic acids are weak acids, and partially ionized means they contain two kinds of particles in water. One, ions as well as molecules. Both will be there. It is nothing but your in electrolysis weak electrolyte. Okay, that only. All the weak acids are weak electrolyte. All the strong acids are strong electrolytes. So you have to use the same terms. That completely ionizes, partially ionizes that part. Coming to inorganic acids, which are also called as mineral acids. These are obtained from minerals. Okay. They need not contain. See, it is not that they do not contain. They actually no need to contain carbon. But whereas for organic, it is must. Okay. But one exception is there, that is carbonic acid, H2CO3. It is an inorganic acid but still contain the carbon. So they may ask you a question, name the inorganic acid which contains carbon. So you have to write carbonic acid. Otherwise, the simple examples are hydrochloric acid, sulfuric acid, nitric acid. And to add here, these are strong acids. Strong acids means they completely ionize in water. Means if you take 100 molecules of HCl, all the 100 molecules will ionize into H3O plus and Cl minus. Okay. Any doubt in this? Clear? Sure. But there is one exception. We'll see that. Now, the question here. Dhruva, are you here? Yes, sir. Can you answer the first one? A particular solution contains molecules and ions of the solute. So, yes, it is a weak acid. Very good. Aryan, what is an organic acid? Weak organic acid? Formic acid. Formic acid. Yes. Remaining three are mineral acids, which are strong acids, and they are not organic. Okay. So, special thing about carbonic acid is, see, when I am explaining, there are some points which I tell you very important. Okay. So, you start making yourself some notes during the class. If you simply see the screen, you will be maybe getting bored. But always try to write something in your notebook, all the important points, something is there. But not everything, only important points. You may be getting the PDF of this, but whatever notes we make, that will be far better. Okay, carbonic acid is a weak mineral acid. So what we learned, mineral acids are strong, but exception is carbonic acid. Two exceptions are there. One, it contains carbon, even though it's a mineral acid, and it is also weak acid. Okay, and it turns blue litmus pink. It is non-corrosive and used in soft drinks. Soft drinks are nothing but whatever cold drinks they are there in the market. Okay, Pepsi, Coca-Cola, Sprites, all of them contain, if you see the label, carbonated water. Means what they will do? They will take the water, cool it, okay, and then they will dissolve CO2 gas into that. Then we will get H2CO3, which is carbonated water, nothing but carbonic acid. Yes. Sir, but don't acids turn red? Yeah, because of this is a weak acid, they might have given it here pink. Okay. Yeah. So carbon dioxide is an exception, right? It turns it light red, right? Carbonic acid, yes, that's an exception. Okay, this is the second kind of classification. First classification was based on the sources, organic and inorganic. This one is very simple. Whether a given acid contains oxygen or not. Okay, simple. If it contains oxygen, what do you call it? Oxy acid. Simple, you know the formula. In the formula you have oxygen, HNO3, H2SO4. Oxygen is there, so we call it as oxy acids. But oxygen is not there. Hydrogen is always there. That's understood. Okay. But oxygen is not there. Then you call it as hydracids. Only hydrogen and some other non-metal will be there, like hydrochloric acid, hydrobromic. Okay. These kind of things. These are called as hydracids. Simple. Okay. Oxygen, if it is there, oxyacid. If it is not there, hydracid. Third one. Actually, this is the main part, that is depending on their basicity. Remember, many of you might have confusion. Acids, when we are learning, we learn the basicity for the acids. Means how many hydronium ions it produces, means how with how many base molecules it can react with. And for bases, we will study acidity. Okay, now acids definition we'll see here. The basicity of an acid is defined as the number of hydronium ions that can be produced by the ionization of one molecule of that acid in aqueous solution. See, in simple words, you take any one acid, say for example HCl. What I will do, I will dissolve it in water. One molecule of HCl I have taken, I will dissolve it in water. Then I will see how many hydronium ions it can produce. So HCl is producing only one hydronium ion. Therefore, we will call the basicity of it is 1. Another example, if I take H2SO4, sulfuric acid, dissolve it in water. Okay. See, in the H2SO4, we have two ionizable hydrogens. Ionizable means what? They can ionize into H plus. You know? So, in first step, I will show you step by step. Only one H will go with water. So, it will form H3O plus. And what is left? Another H is left with sulfate. So, it will become bisulfate, HSO4 minus. But this HSO4 still has one more H. So that will continue when you take another molecule of water. Okay. That H is also gone to water. So you will get H3O plus another one and SO4 minus 2. But what we generally do, we don't write it step by step. We just show in one simple step. See, this HSO4 is in the reactant side as well as the product side. So cancel it out. Now whatever are remaining here, H2SO4 plus how many water molecules? 1 plus 1, 2. How many hydronium ions? 2 and sulfate ion. So this is actually the final reaction. So you can see here how many hydronium ions per one molecule of acid you are taking. You are getting 2. Therefore, the basicity is equal to 2 for sulfuric acid. Okay. But don't consider that how many hydrogens are there, that will be the basicity. Okay. Exceptions are there. Example, CH3COOH. In this you can see H3 plus 1 H, 4 hydrogen atoms, but all of them will not ionize. Only the H which is attached to oxygen will ionize. The H attached to carbon will not ionize. So what it will form? It will form acetate, CH3COO minus anion plus H and H2O will give you one hydronium ion. Therefore, what is the basicity of acetic acid? It is again 1. Okay. So, it will depend upon the number of replaceable hydrogen atoms, not on the total number of hydrogen atoms. Okay. So, I think replaceable number means when you dissolve that particular substance in water, only that those many hydrogens will ionize and you will get those many number of hydronium ions. Here, In HCl only one hydrogen is there, so it is giving one hydronium ion. In H2SO4 two are there, both of them will ionize, so you are getting two hydronium ions. But in CH3COH you totally have how many? H3 plus H, four hydrogens. But out of four, only one hydrogen is ionizable, which is attached to oxygen. Therefore, it will give you only one hydronium ion, not four, right? This H attached to carbon, that will not ionize. It remains as it is. Okay, now? So that will be the difference. If the basicity is 1, we call such acids as monobasic acid. Mono means 1. Okay, monobasic acid. If the basicity is 2, dibasic acid. Can you please mute Ayuna? And for acetic acid is also the basicity is 1. So acetic acid is also what? It is a monobasic acid. Okay, you just have to know the exceptions. One is acetic acid. One more is very important. H2, sorry, H3PO3, H3PO4. These are two acids, H3PO3, H3PO4. Can anybody tell me the name of these two? What is H3PO3, H3PO4? Hmm. This one is phosphorus. Yes. Yes. This is rus. This is phosphoric acid. Okay. So phosphoric acid, you have three hydrogens. All of them are replaceable or ionizable. Therefore, its basicity will be 3. So you call it as tribasic acid. But don't do that mistake with phosphorus acid. Here also three hydrogens are there, but all the three are not ionizable. See, for your understanding, yes, I will write the structure here of this, but you no need to know this, but for your understanding, I'm telling you here. See, only the hydrogens attached to oxygen. You can see only two are there. These two are ionizable, means when you dissolve them in water they become hydronium ions, but the one which is here directly attached to phosphorus, it is non ionizable, means it will not form any hydronium ion. Therefore it is basicity is actually 2. Yes, we call it as a dibasic acid. Okay, so this is the exception which you have to take care of. Fine. And for tribasic acid, phosphoric acid, you can remember. Dibasic acid ke liye one more example, which is organic acid, that is oxalic. Oxalic acid is also an example of dibasic. I told you na, COOH, COOH. So there are two hydrogens, both of them are replaceable or ionizable. And HNO3, that is anyway one hydrogen, whichever contain one hydrogen and their acids, means their basicity is one only. Lastly, just for your uh, very difficult question paper, if they give you, they may ask you give an example of the acid whose basicity is 4. Okay, so one example you can remember, H4SiO4, its name is silicic acid. H4SiO4, whose basicity is 4, silicic acid. Okay, so these are the classification depending upon the basicity. I hope everybody understood. If there is any doubt, please get it right now. Anybody has any doubt? Sure. Sir, can you explain the H3PO3, how is it only irreplaceable? Okay, see the structure here for H3PO3. Okay, so you can see out of three hydrogens, two hydrogens are attached to oxygen. Okay, and one hydrogen is attached to phosphorus. So when you dissolve this in the water, only the hydrogens attached to oxygen, they will ionize. Means they will become H3O plus. But the one which is attached to phosphorus, that will not ionize. Therefore, even though three hydrogens are there, only two hydronium ions it will form when dissolved in water. Hence, it is a dibasic acid. Okay. Huh. There will be lots of reasons. See what happens that you learn in higher grade. Compared to oxygen and phosphorus, oxygen's electronegativity is more. So whenever hydrogen leaves, it will form a negative charge on the oxygen. है ना? So oxygen can hold that negative charge because it is more electronegative. Same thing happens with this oxygen. But phosphorus is not that much. And it already has 5 bonds. है ना? So it is very difficult for it to hold another negative charge on it. Okay. Chalo. So again, if they ask you give reason also, you have to explain simply based on the definition only. For example, if they ask you reason for why acetic acid is a monobasic acid, you go with the definition only. That when one molecule of acetic acid is dissolved in water, it forms only one hydronium ion. Hence, its basicity is 4. Sorry, 1. Even though it has 4 hydrogens, only one hydrogen it is ionizable. Remaining 3 are non-ionizable. Yes, same thing. Okay, whatever they give you, ask you give reason on this basicity part, go with the definition only. How many hydronium ions is there giving in water? Okay. Chanvi, can you answer this one? Select the acid which contains 4 hydrogen atoms in it. Correct. Yes. Formic acid also, remember children, you already know the formula HCOOH, right? It also has 2 hydrogens, but only one hydrogen is replaceable. So formic acid is also what? Monobasic acid. So here the question was how many? Acetic acid has 4 hydrogens. CH3COH now. Hmm? Fill in the blank from the choices given within bracket. The basicity of acetic acid we just discussed, it is 1, not 4. Okay, most important part next one is about the indicators. This one do not do mistake. Huh? Very simple questions will be there on this. If it comes for like 2 to 3 marks, then it is a jackpot. Okay, so litmus anyway, if some of you don't remember how to remember this thing, don't know how to remember means remember acid is always red, base is always blue for litmus. Matlab DD BB. Okay, DDBB. Acid, you take red litmus or blue litmus, it becomes red only. Base, you take red litmus or blue litmus, it becomes blue only in base. Talking about the methyl orange. For this, I think in the regular class I told you one mnemonic to remember. Poi. Okay, remember this word, poi. P for pink. Pink in acid. Y for yellow. Yellow in base. And what is O? O is its original color, that is orange. In the neutral condition, or you can say just actual color. So if they ask you what is the color change of methyl orange when you put it in the acid or in HCl solution, okay, it changes from orange to pink. And in the basic condition, it changes from orange to yellow. Pink, or sometimes they may give you red, then red also you can select. Okay. Chalo. Lastly, phenolphthalein. Phenolphthalein color, it gives pink color only in, yes, basic condition, basic solution. In all other cases it remains colorless. So you just remember that phenolphthalein will give you pink color only in basic solution. In all other cases it is colorless. Okay, they may change this and little bit and give you what happens when you take alkaline phenolphthalein. Alkaline. What is the meaning of alkaline phenolphthalein is you taken phenolphthalein and you already added some alkali. Alkali is nothing but a base. So it is already a pink colored solution. है ना? Now if you take alkaline phenolphthalein and add it to acid, then it becomes a pink to colorless solution. Okay. So these are the four things they will ask you. I will not explain this again in the base part. So I have explained it for both acid as well as base how the color will change. Okay. If you take alkaline. Yes. If you take alkaline phenolphthalein, add it to base, it remains pink only. Okay, coming to the next question. Tanisha, can you please answer this question? Not produce an acid when made to react with water. Tanisha, are you there?
Yeah, so can you hear me?
Yes.
Hello. What's this now?
Which one of the following will not produce an acid when made to react with water?
One second. Monoxide, carbon monoxide. Carbon monoxide.
Correct. Carbon monoxide. So, to understand the reason for this, you should know that non-metallic oxides are two types. One, they are acidic oxides. And if you take acidic oxide and dissolve in water, they will definitely produce acid. Whereas some of them are neutral oxides, like carbon monoxide you take, or H2O you take, nitrogen monoxide you take, the one which contains single oxygen. Only the non-metallic I'm talking, not the metallic. Okay, so non-metallic oxides which usually contain one oxygen atom, they are neutral oxides. So neutral oxides, they will not form acid in water, therefore they will also not change the color of the litmus paper. Okay, if they ask you what happens. Yeah.
So I have it. So from H2SO4 as a chapter, SO2 also will not form an acid, right?
SO2 will form an acid when you dissolve in water. No? What acid it will form is H2SO3. Sulfurous acid. Sulfurous acid is strong acid. Strong acid. H2SO4 is different. H2SO3 is different. You may be think, hmm. Might be, but if you say controlled condition, I am doing this in very cold condition. Okay, now then whatever acid forms, whether it forms an acid or not, it is forming. Then it is acidic oxide. Okay. Sulfur trioxide is also acidic oxide. When you dissolve it in water, it will form sulfuric acid. But we don't use it. That is totally different story. Okay. But whether the question here is what type of oxide is that? How do we know? You dissolve it in water, test it with the litmus, you will come to know. Okay. But important thing here is neutral oxides do not change the color of the litmus. Chemical properties of acids, very important and applicable for all of your reactions of HCl, HNO3, H2SO4. Okay, so what I am going to give you here is all general reactions. So what you have to remember here is for typical acid reactions, you always have to write dilute. Only dilute acids will show this property. Which are those? You will take dilute HCl, you can take dilute H2SO4, you can take dilute HNO3, or even the organic acid, dilute CH3COH, acetic acid. All of them will give you same reactions. So one general equation thing I'm giving you here, so you can make note of this in one paper. Take acid. General acid means all of these four. ठीक है ना? Now this acid I will make it react with the base. We know acid plus base is what kind of reaction? Neutralization reaction. What it will give you? Salt and water only. Okay. Second, you will react it with active metal. Active metal means the metal which is above hydrogen in the reactivity series, not the one below. Okay. So acid plus active metal will give you respective salt plus hydrogen gas. Remember, there is an exception here for dilute nitric acid. We know the reason already. Dilute nitric acid is a powerful oxidizing agent. It oxidizes hydrogen to water. Hence, we don't get hydrogen if you take dilute nitric acid with metal. Okay, so we have to keep this in mind. And but we can still get hydrogen with couple of metals. If you take very dilute nitric acid with magnesium and manganese, will give you hydrogen gas. Okay, that I will cover in the next part. Third one, metal carbonate or bicarbonates. Generally, I'm telling metal means you can take sodium carbonate, potassium carbonate, calcium carbonate, calcium bicarbonate, any metal carbonate or bicarbonate. When it reacts with acid, you will get respective salt, water. Yes, the gas released here is carbon dioxide. No, that carbonic acid will not be stable, hence we don't write it as carbonic acid. We will split and write it as H2 and CO2. Okay, now next, metal. Are you able to hear me? Huh. Metal sulfite or bisulfite. Remember sulfite, not sulfate. SO3. Metal sulfide, SO3. Okay, na? So here also you will get similar salt plus water plus SO2 gas. Wherever carbon is there, you have to replace it by sulfur. So you will get, instead of CO2, you will get SO2 here. Lastly, with metal sulfide. Metal sulfide. Sulfide is S minus 2. For example, FeS you take. FeS is an example of that. So in this case, you will get salt and yes, the rotten egg smell, the gas which is having rotten egg smell. So these, if you just remember this one, you are remembering like 20-30 equations. Because wherever acid is there, you can put any acid there. HCl, H2SO4, HNO3, acetic acid, anything. But only thing you should know what salt you will get. Respective salt you have to write. Okay, that I think by now we should know. And different kind of questions will come from this only. Like one is write the balanced equation. Okay. Second one is write the, sorry, identify the gas released. Write the observation or write the test for the gas released. Okay, it is integrating your practical chemistry also. Fine. So please raise your hand who can tell me what is the test for hydrogen gas. Yes, Dhanesh. Okay. Are they asked you to write that pale blue flame wala example?
Something in textbook as if I remember.
Okay. Um, Fine. But usually we can just write colorless, odorless. Okay, hydrogen is colorless and odorless. A colorless, odorless gas which extinguishes the flame with a pop sound. That much also, if you write, that will be correct. And for CO2 and SO2, that's very important. Both of them, first you have to write lime water test for both. So both of them will show the lime water test. What is that? Changes the lime water into, turns lime water milky. Both of them. Second part, how you distinguish? You will use acidified KMNO4 solution. You have to write completely. Many of you simply write KMNO4. No, acidified potassium permanganate solution, or you can use acidified potassium
Yeah.
dichromate solution, right? So,
So if we do this solution, you need marks.
huh, yes,
This solution.
yes. This test is shown by SO2 only. CO2 will only change the lime water milky but has no effect on both of them. Whereas SO2 will change the color for both of them. Okay. What is the color change for KMNO4? Iona, acidified KMNO4 change in the color?
It KMNO4,
Hmm.
is it pink to colorless?
Yeah. And for second one?
Orange to green. So green to clear colorless, no?
Right.
Yeah,
Orange
depends
to
upon the.
right. Yeah, you can write clear colorless or simply colorless, orange to green. Hmm? This part. And for H2S, first of all, H2S simply we can identify it by the smell. It is rotten egg smell. But if they ask you to write the test also for H2S, we will write moist lead acetate
Acetate paper.
paper, silvery black. When you show the moist lead acetate paper to H2S gas, it will change the color of the moist lead acetate paper silvery black. Or if you take a solution of lead nitrate once again, no? Or if you take the solution of lead nitrate, then you will get a black PPT. Because in both the cases, what you are getting is lead will react with sulfide and it forms PBS. PBS, which is a black PPT. So therefore, the paper changes to silvery black. And if you take the lead nitrate solution itself, then it will form a black PPT. Okay. Yes, Danish, you have any doubt?
So can you also mention the acidified lead, no, wait, potassium dichromate permanganate
Huh.
solution?
For H2S, na?
Is that also correct?
For that, what will happen there?
Like, it won't be colorless. It'll just be like green, orange, and yellow. I mean, this. So in SO2, it's pink to clear colorless, no?
Hmm.
Orange to clear green. In H2S, it's pink to
Hmm.
only colorless, not clear. Due
Okay.
to sulfur. Yeah.
Huh. Colorless, but you will also see some yellow particles in it. That's sulfur
Is that correct
particles.
if you mention it?
Huh. But usually don't do that. Okay, na? Only if that particular question only comes. Okay, like I think it might have come in your term exam, it seems. Okay, then you write H2S gas. Otherwise, just write the lead dusted wall experiment, observation. Okay, this will be easy. Then because SO2 will be totally different, H2S will totally be different tests. Okay, yes, Rishi.
Sir, if they tell us to write like give a reaction for acidified KBCl
No, no,
compound.
no. They will not ask you to write the test reaction for acidified KMNO4 and all. Okay. Practical chemistry only observation. And if it is given in your remaining chapters, any equation is related, only that will be asked. Okay. This will not be asked. Okay. So based on that, let's see some questions. When dilute sulfuric acid reacts with iron sulfide, Okay, Vanishika, can you answer this question?
Yes, sir. Is it hydrogen sulfide?
Yes. Remember, children, sulfide say sulfide only you will get. Many of you write SO2 gas, which is not correct. FAS is sulfide now, and you're passing H2SO4 dilute. So you will get respective salt ferrous sulfate and H2S. And whenever they ask you write the equation, definitely you have to write dilute. If you don't write dilute, then your marks will be gone, even though everything is
So
correct.
with 2 FES, right? You said
Huh, balancing you can do. Okay. No, it is already balanced now. Hmm.
so
SO4.
there's two S's.
No, no, SO4, SO4.
Oh, I know.
Huh. Okay. So here, this is a second kind of question where you have to identify the gas. So always write the name of the gas. Don't take any risk by writing the formula. Just write the name, that will be enough. Okay. Here, sulfur is heated with conc nitric acid. So this is from your nitric acid chapter. Wherever concentrated is there, that is from that particular chapter only. But if it is dilute, you can use all the typical acid reactions what we have mentioned here. Okay. So here dilute this, leave it. The potassium sulfite is treated with dilute hydrochloric acid. This one, Ruhani, can you tell me the answer?
Yes, sir. Sulfur dioxide.
Very good. Okay, I'm writing here formula, but you have to write the name. ठीक है ना? Concentrated again. This we will learn in HCl chapter. The gas
Fluid,
evolved.
right?
Huh?
Fluid, right?
Huh. The gas evolved on reaction of aluminium with boiling. Again, this is different. The gas produced when copper reacts with conch. Again, different. Huh, this one. The gas produced on reaction of dilute sulfuric acid with metallic sulfide. Just now we have seen. Metallic sulfide के लिए Darshwana, what will be the gas?
Hydrogen sulfide.
Yes, H2S. Okay, some word or words missing. You have to put that word. See here, this is a statement. You have to tell what word is missing here. Hmm? So raise your hand. Who knows?
The dilute nitrogen.
Not dilute.
No, no, you said dilute oxidizes H2H2O.
Yes, yes. But you have to use very dilute. Dilute only is not enough. Very dilute nitric acid. This is the exception I was telling. Dilute if you use, it will not be. Very dilute matlab how much? Right? We should have some value, na? So usually it will be 1% solution. Percentage means you can say 99% of is water, only 1% is nitric acid. That's how you can understand it. So when you take very dilute nitric acid, it can give you hydrogen only with magnesium and manganese. With these two elements only gives hydrogen. I think this has been asked as a MCQ also in one of the papers. Which of the following will give you hydrogen gas with very dilute nitric acid? So any one of these two you can select. Okay, again, what will be asked? They will be asking you to write the balanced equation. But at least by now you should not do that mistake of not writing dilute. Okay, na? How many of you lost marks in the prelims? I don't know, for not writing dilute. Calcium bicarbonate reacts with dilute hydrochloric acid. So bicarbonate formula, many of you write incorrect. What is the formula for calcium bicarbonate?
CaHCO3. Hold twice.
Ah, CaHCO3 whole twice. If you write this equation, sorry, formula itself wrong, then everything will be wrong. Then dilute HCl. So what is this? General typical acid, what I told you, acid plus any metal bicarbonate or carbonate will give you salt, water, CO2, right? So salt will be
CaCl2.
CaCl2, water and CO2 gas. Okay, this is how we have to remember. So that's why I told you don't try to remember individual equations. Whatever total I gave you general equations, that you remember. Hmm. Chalo, I think here what you have to do, 2 HCl. That's it.
CH.
Carbon, 2
Carbon.
are there.
Carbon, yeah.
2 to 4, so 2H2. Done. Okay.
Yes.
Second one, lead nitrate solution is added to sodium chloride solution. This is actually precipitation reaction, but still we will write here lead nitrate plus barium fluoride. Double
So
discount.
how do we know if it's red? What's the
Huh. Yes, what you are telling?
so how do you know that lead is variable valency? Like how do you know which lead you choose? Like this is
Generally, don't worry if they don't mention valency. Always take lead nitrate is PbNO3 2 only. Okay, na? It is for 10th grade, it is fine. If they specifically mention lead 4 oxide, then only you have to worry about. Okay, na? PbCl2 plus NaNO3 to NaCl. ठीक है. So this is the precipitation reaction which I will explain you during salts formation. Okay. Okay, coming to bases. In the bases part, we don't have much like typical basic reactions, not like acids. Okay, any preparation methods. Don't worry much about that part. Only important reactions which we have already covered in different chapters. So that only we have to use. But first of all, we have to understand the meaning of bases. See, base is either a metallic oxide, a metallic hydroxide, or ammonium hydroxide. Not a non-metal, it should be a metallic. For example, metallic oxide is MgO, metallic hydroxide NaOH, or only one non-metallic hydroxide, that is NH4OH. Here you don't have any metal, but still it is a base. Okay, this one thing you should know, which reacts with hydronium ions, you can say, or you can say acids, simply acid, to form salt and water only. This only word again you have to put. If it is forming something else along with salt and water, then it is not. For example, we have seen previously calcium bicarbonate is there. It is forming salt water as well as CO2. Therefore, calcium bicarbonate is not a base. Only salt and water, if it is forming with acid, then it is a base. Okay. For example, copper oxide, magnesium hydroxide, etc., etc. Neutralization reactions you already know. A lot of times we have done this, right? Okay, find the odd one out, explain the reason for your choice. ठीक है. Let's okay, who is left? Rishi, tell me what is the answer for this? Rishi Kumar.
yes sir, yes
Hmm.
sir.
Aluminium, lead, magnesium, zinc. What is the difference? Hmm. Okay, I will give you a clue. One of them is a basic oxide, other three are amphoteric.
Yes, aluminum oxide.
Mhm. Magnesium hydroxide, it's a basic, and remaining three are amphoteric. So children
Could you also
remember. Hmm.
so could you also write the other differences? PbOH and then they're all diacidic, but NH3 is
Ha ha ha.
acidic.
Ha. Yes, yes, yes. That is also correct. Yes. Aluminum hydroxide also you can say by telling that it is a triacidic base based on the classification, and remaining three are diacidic bases. Yes, based on your reason that would be correct. Okay, or we can say this one magnesium hydroxide because remaining three are amphoteric. Okay. The metal oxide which can react with acid as well as an alkali. Yes, this is the definition of amphoteric oxides. Okay, so you have to remember, under basic oxides all are basic only except three which are called as amphoteric. Those are aluminium, zinc and lead. Their oxides and hydroxides. Only these are, even though they are metal oxides, they are amphoteric. Means they can react with acid as well as an alkali to form salt and water. So here straight away aluminum you can select. Okay, I will give you one example. Say for example zinc oxide. So if you bring an acid to it, dilute, HCl is an acid. It will form salt and water, ZnCl2 plus water. And same zinc oxide, if you bring a base, sodium hydroxide, then also will form salt and water, but the salt is different, Na2ZnO2, sodium zincate plus water. Therefore, zinc oxide in the first case it is acting as a base, in the second case it is acting as an acid, right? And in both the cases it is giving the salt and water. Hence we call it as amphoteric oxides. And one more thing about them is no change in color of indicator. They do not change the color of indicators. Neutral oxides like CO, NO, H2O, or you take amphoteric oxides. These two will not change the color of the indicators. Okay, fill in the blanks. When a metallic oxide is dissolved in water, the solution formed has a high concentration of. Okay, metallic oxide, always metallic oxides or hydroxides will give you OH minus only. Say NaOH you are taking, dissolve it in water, it will dissociate into Na plus and OH minus. So you will be having hydroxide ion as the only negative ion. Or you can take say for example potassium oxide is there. It will form potassium plus hydroxide only when you dissolve it in water. Oxide becomes hydroxide when you dissolve in water. Therefore, you have to give here OH minus. For bases, it is always OH minus negative ion, and for acids, it is hydronium ion as the positive ion. Okay, alkalis. See, this difference we should know. What are alkalis? Simple words. An alkali is a base soluble in water. Okay, very simple. All the bases are not soluble in water. Only some of them are soluble in water. Those are called as alkali. What you have to remember here, two strong alkalis and two weak alkalis. Again, what do you mean by strong and weak? If it is
Ionization.
completely ionizes, it is strong. If it partially, okay, here it is dissociating, then it is weak. Okay, so couple of them are sodium hydroxide, potassium
OH.
hydroxide. But remember, alkali metals, group 1, alkali metal hydroxides. All of them are strong alkalis. Not only sodium and potassium, these are the common things we use. But in the first group, what else we have? Lithium we have, right? Rubidium, cesium. Those hydroxides are also strong. They are soluble in water. Coming to weak, you have to remember ammonium hydroxide and calcium hydroxide. Only these two examples you have to remember as weak alkalis. Again, same questions like which one will conduct electricity better when dissolved in water. Again, depends on strong and weak only. Hmm? So NH for OH or NaOH, NaOH because it is a strong base, strong alkali, right? So alkali is a basic hydroxide which when dissolved in water produces hydroxyl ions as the only negatively charged ions. So what about copper oxide? Copper oxide is a simply base, not an alkali because it is does not dissolve in water. Okay, only these few of them dissolve in water. Based on just like we did for acid, we are doing it for base. We call it as acidity of a base. So when you dissolve a base in water, how many OH minus ions it gives us, that will be the acidity of the base. Or sometimes because all of them don't dissolve in water, right? Then it will be the number of hydrogen ions with which a molecule of that base will react. Means how many acid molecules or H plus it will react to form salt and water in the neutralization. So here no conflicts and no exceptions. Just to see how many OH is there in the formula, that will be the acidity. So for example NaOH may only one OH is there now. So its acidity is 1. Magnesium hydroxide may you have 2 OH, OH twice, right? So its acidity is 2.
two.
Aluminium hydroxide may 3 because 3 OH are there. Simple. Straight question.
Sir,
Yeah.
can I?
Yeah, yeah. Yes. Okay. And similarly, we call this as monoacidic base, diacidic base. Remember, many of us will have confusion with this triacidic base. Okay. For acids, we call them as monobasic acid, dibasic acid, tribasic acid. But for these bases, we call them as monoacidic base, diacidic base, triacidic base. ठीक? Indicators we have already discussed. One point we have to know here, if the base is insoluble, then it will not change the color of the indicator. Insoluble bases do not affect indicators. Okay, because they don't form hydroxide ion only. How can they give you color change, right?
It doesn't dissolve in the water.
Yeah, they don't dissolve in the water. Yes.
Yeah.
Okay, identify the substance underlined in the following case. A solid formed by reaction of two gases, one of which is acidic, other is basic. Remember, whenever they give you basic gas, acidic gas, okay, I will explain it once again. HCl is always acidic gas and ammonia will be a basic gas. This you should know by now. So when they react, you know, you will get NH4Cl. That is the solid. But you have to write the name ammonium chloride. Okay, one give reason question I have included here, that they means bases. Okay, are soapy substances. That is, they are slippery to touch. Okay, especially not bases. We have to call it as alkalis, because only which are soluble in water will give you that slippery feeling. Okay, so you can see here caustic soda and caustic potash. Caustic soda means what? Yes, caustic soda, caustic potash. What is it? Aryan, tell me.
NaOH, KOH.
Caustic soda is nothing but NaOH. Caustic potash is nothing but KOH. These are the common names. Okay, we should know this. So what happens? They are strong alkalis, right? Means they completely dissociate when you dissolve them in water. Therefore, they are strong. Alkalis react with oil to form soap. So soap formation we didn't learn, but simple way. Take alkali, take oil, it will react and form soap. So since our skin contains oil in the form of fat or anything, lot of oil substances are there in our body, skin also contains that. So that will react with the caustic soda you which or caustic potash which you have touched. There itself the immediate reaction takes place and basically you are producing a soap there. So means that makes you, you know, makes you feel that slippery to touch thing. Okay, the reason is simple. The caustic soda or caustic potash, which are strong alkalis, they will react with the oil present in the skin and form soap. Okay, therefore, this is the reason for that. Chalo. Chemical properties of bases, we don't have much. We have a lot of things which we're going to cover in the next part only. Say, for example, when you take ammonium substances, this is nothing but laboratory preparation of ammonia gas and treat it with an alkali, sodium hydroxide, potassium hydroxide, calcium hydroxide under heating, you will get salt, water, and ammonia gas. Salt here is CaCl2, water, and ammonia gas. This is one reaction. Okay. Another reaction will be when you react with an acid, we have already seen the neutralization reaction. Or when you treat it with the acidic gases like CO2. Okay, say CO2, you're passing it through sodium hydroxide solution. So what it will form? Sodium,
Na2CO3.
yes, sodium carbonate.
Yes.
plus water will be there. This is your test for lime water, where you will use calcium hydroxide instead of NaOH, right? Calcium hydroxide is a lime water. Lime water is actually calcium hydroxide dissolved in water, but it is partially dissolves. Okay, what they do, they shake it properly, settle down the solid, only decant the solution, that they will use as a lime water. Then you will get calcium carbonate, which is milky substance along with water. This reaction also we already know, and lots of other reactions which keeps on coming in upcoming chapters. Okay, lastly, this pH we will understand. See, pH is a scale where the value ranges from 0 to 14. In between you will have 7, and the region between 0 to 7 is acidic region, and 7 to 14 is alkaline, and 7 itself, if it is there, it is a neutral substance. Okay, very important, when you move from 7 to 0, acidic strength, okay, increases in acidic strength. Okay, and for basic it is reverse, 7 to 14 it has to increase. Okay, then it will increase in basic strength or alkaline strength. Basically, lower the pH, okay, stronger the acid. Similarly, higher the pH, stronger the base. Okay, na? Simple thing is there.
Is there any substance that's zero pH?
Huh? Acids have zero pH. Matlab they are very strong acids, like sulfuric acid, concentrated sulfuric acid. Okay, those things. pH actually, if I have to give you what is the meaning of pH, it is actually a calculation of how many H plus it is forming when you dissolve in water. It is a minus log to the base 10 of H plus concentration.
So it's important.
No, not needed. Okay, but it's actually a mathematical expression based on which we will get some value for pH. Okay, now, so if the, because it is a minus log to the concentration of H plus, the more number of H plus means it's a strong acid now, so pH will be less, and if the less number of H plus are there, means it's a weak acid, so pH will be more. Okay,
So
therefore
in
when,
higher grades, will they tell us to calculate pH?
no, this formula they will not ask you anything. Hmm? Only they will ask you this one, they have given lots of examples now. pH is this, what is, which one reacts with, as changes the color, reacts with a base, those kind of questions will be asked. How you increase, how you make a neutral solution into a basic solution, huh? Neutral solution into an
So
acidic
what in higher
solution.
grades? What about in higher grades?
Higher grades they will ask you. Higher grades, lot of things are there. This is nothing. Okay. To increase, okay, this was I am talking about. Isha, can you tell me the answer for this one? To increase the pH value of a neutral solution, we should add an alkali, correct? Because alkali will be a basic solution. So pH we have to increase from above 7, matlab we have to add an alkali. Very good. Okay, Dhruva, tell me the fifth one. Higher the pH value of a solution, the more dash it is.
Alkaline.
Alkaline. Chalo. Okay, now we'll come to the next part. Shall we take like just 2 to 3 minutes break? Okay. Now we will go to the last part of acid, bases, and salts. That is salts. Okay, lots of questions will come on this part, like equations or simple 1 mark question also will come on this. So basically, first of all, the classification we'll see. Hmm? So we have acidic salt, normal salt, and basic salt, right? Here, just now what we have studied about acids and bases, depending upon their basicity of an acid and acidity of a base. Only those substances which have more than one hydrogen atom, replaceable or ionizable hydrogen atom in them, they can form acidic acidic salts. Okay, because if only one hydrogen is there in the acid, say HCl, okay, so that H itself will go and react with the base. So you will get a normal salt, NaCl plus H2O. What is a normal salt? There is a complete neutralization. What is this? Complete neutralization of an acid by a base or of a base by an acid. Then it is a normal salt, whatever forming NaCl. So how to identify normal salt? Very simple. It will not have H or OH in it. Okay. Simple way to identify normal salt is it will not have H or OH in it. Say for example, acidic salt, if we have to see, HCl cannot form acidic because it has only one H, that will always go completely. But whichever have more than one hydrogen, those can form acidic salts. For example, H2SO4. So in H2SO4, we have two replaceable hydrogens. Correct? Therefore, the basicity is 2. Imagine it has reacted with NaOH. Okay. Only one H is gone, but another H is as it is. So what you are getting here, NaHSO4 plus H2O, right? Only one H. See, one H and HSO4. This is how I am writing it. So this H is gone with OH of the NaOH. And this Na will combine with HSO4. So we are getting NaHSO4 plus H2O. This is acidic salt. So how to identify acidic salts? It will have,
Hydrogen and salt.
yes, hydrogen in its salt. Okay. Similarly, you can say NaHCO3. This is
So the
also,
preparation of HCl is by acidic salts, right? Using them. Like it's a byproduct.
HCl in which case?
The laboratory preparation. Like
Huh.
NaOH
Ha
is
ha. Yes. Yes, that is a byproduct. See, that salts can be formed in any kind of reactions. It not necessarily should be between acid and base. Like in preparation of HCl also, yes, what you said, we are taking NaCl and concentrated sulfuric acid we are taking for that particular reaction. That case also you're getting one salt, that is NaHSO4 when you're doing it below 200, right? Plus HCl. So this is what kind of salt if they ask you, this is acidic salt. See, it doesn't matter what reaction we are using, but what is the nature of the salt we are getting, that is important. So if there is H in the salt, then it is an acid. How do you know it is a salt or acid? Salt always contain metal. That is understood. Huh? Salt always contain metal in it. Along with the metal, you have any H, then it is acidic. Say KHSO4. Okay. Uh, KCl, KNO3, they are all normal because there you don't have any other H or OH. Okay. Coming to basic. Now what you should have? You should have a base whose acidity is more than 1. Means it should have more than one OH. NaOH can never form a basic salt. KOH, no. But you take MgOH2. It has 2 OH and I am treating with HCl. Okay. We are doing here partial neutralization, not complete. Okay. So only one OH will go with H. Another OH will remain with Mg only. and Cl will come with Mg plus H2O. You can see this is a salt again, Mg in bracket OH Cl, but this is a basic salt. Okay, when you will get a basic salt, when the base has more than one OH and it is not completely neutralized by an acid, then you will get a basic salt. And how to identify basic salt? Simple. There should be, it must contain OH in it along with another non-metal. Like here Cl is there. If it is simply OH, then it should be a base, right? Or CaOH SO4. SO4 cannot form this. NO3. Okay, like this. OH is there, along with that some another anion is there. Then it is a basic salt. So by definition, you have to go by the book only, but I have explained. If it is a complete neutralization of an acid by a base, you will get normal salt. A partial neutralization of an acid by a base, then it is an acidic salt. And this one, partial ionization of a base by an acid, it's a basic salt. Okay, these definitions are there. Usually they will give you this for state the term, name the following questions. Okay, now comes the most important preparation of salts. Okay, so be careful and be attentive. I'm going to give you simple techniques which will avoid your confusions if you follow it properly. First of all, we don't have many things. We have only three types of preparation methods. They will ask you either preparation method or equation or mix them both. Okay, now first of all, direct combination, which is also called as synthesis. So always which question is asked on this? FeCl3. FeCl3. So how it is formed? Fe plus Cl2 FeCl3. Combination reaction, single product. Right? I'm not balancing, I'm just giving you the salts. Fe plus 3 state, iron 3 chloride or ferric chloride. This is one example you have to remember for direct combination. But another example, if you want, AlCl3 can also be prepared with the same method. Okay. Second one, these are all not new for you, but you should know how to use them. Simple displacement reactions. So simple displacement where you see when you take any metal, active metal plus acid. Yes. Huh. Any active metal plus acid. So sir, how to know this? Say for example, they will ask you FeCl2. Anyway, FeCl3 is combination that you have to remember. FeCl2, how can I get? I will take Fe, I will treat it with HCl, dilute, then I will get FeCl2 plus H2. So any active metal is there and you're getting its salt. You want to get its salt, then you have to use simple displacement reaction. Similarly, you can use zinc sulfate. Okay. Uh, hmm? PB. What you're telling? I didn't get. Balancing you're doing. Okay, okay. Okay, now zinc sulfate. But remember, whatever salt you're getting here, you are getting the soluble salts. Okay, but anyway, here we don't have precipitation or water. Okay, dilute HCl is there now. Okay, you are getting here soluble salts. If it is insoluble, then you can't use this method. I will tell you which are those. Okay, other active metals like you have magnesium chloride. Okay, copper compounds you cannot use simple displacement. Remember, copper compounds cannot be prepared. Why? Darshwana, can you tell me why copper compounds cannot be prepared by this method?
Sir, because they can't be displaced.
Yes, simple. You have to use active metal, whereas copper is below hydrogen, right? Hydrogen is here, copper is here, or any metal below copper, like silver also you can't use. Mercury you can't prepare using this method because it will not displace hydrogen from the acid. Okay, simple things. If you understand, it will become very easy for you. Third one, double displacement or double decomposition, both are same. Okay, but under this we have specific things. First I will explain you precipitation. Under this you will have precipitation and neutralization, both of them under double displacement or double decomposition only. But precipitation, where when you have to use precipitation reactions. Okay, first of all, whichever form precipitate I am telling you here, carbonates. Okay, carbonates of like zinc, lead, copper. Okay, lots of things, calcium, magnesium, except sodium and potassium. Hmm? All of these will form the precipitates. Okay, and to be specific with lead, lead will form lead chloride as a precipitate, lead carbonate, lead sulfate. Okay, these all are precipitates. And apart from this you have general things, you know, AgCl is a precipitate, barium sulfate, AgCl, barium sulfate, these two. And
Barium chloride.
no, barium chloride is soluble. Okay, you will use it as a reagent.
Yes.
Huh. Here I will write not form peptide. Which one will never form precipitate? Sodium and potassium compounds.
Ammonium.
As well as ammonium. Yes. Sodium, potassium, and ammonium compounds. They are always soluble in water. See, precipitate means what? It is not soluble in water. If it is soluble in water, then it will not form any precipitate. Why I'm giving you this? If they ask you, how do you prepare NaCl? You should never match it with precipitation. Okay? You should match it with neutralization. Okay, second one, all metal nitrates, all metal nitrates soluble. Lead nitrate, if they ask you, it is a soluble salt. Don't write the precipitation for that. Okay, any metal nitrate, silver nitrate, okay, sodium, potassium, calcium, zinc, they will never form any precipitate. They always soluble in water. But these two things, if you know this, you can use it to write the reaction for this. How? One simple example I will give you. Say they will ask you to prepare lead sulfate. First of all, you should know lead sulfate is a precipitate. Then only you can write the equations. Sometimes they will mention directly prepare lead sulfate by double decomposition or precipitation method, or using some reagent also they can mention. Okay, those we will see. But one example I'm giving here. See, lead sulfate precipitate I want to get, but I don't know. See, precipitation reaction ke liye whatever starting material you are taking, they should be soluble in water, right? You have to take the aqueous solution of lead compound, aqueous solution of sulfate compound. Now I don't know which compound of lead is soluble in water and which compound of sulfate is soluble in water. In such cases, always what you do, for the metal, you take always the metal nitrate. Okay, whatever metal it is. Here it is lead, but if it is barium sulfate also, you take barium nitrate. And for the second part, you take always for sulfate or any other chloride, okay, carbonate, anything is there, you take its sodium or potassium or ammonium compound. Say for example, here I will take lead nitrate, which is soluble in water, correct, plus sulfate, sodium sulfate I will take, Na2SO4, which is soluble in water. Now just exchange the ions, lead sulfate plus 2NaNO3. Okay, so your most of your problems are here only what you have to take. So this is how you have to solve such kind of problems. Whenever precipitation is there, you use for the metallics nitrate you take. For the non-metallic part, sulfate, chloride, okay, sodium or potassium, you take the compound of that. But some compounds of things are soluble also. Like for example, zinc is there. Okay, zinc sulfate is soluble in water. But if you know that zinc sulfate is soluble in water, that you can take. Okay. And lastly, we have in this neutralization. This is a second part of double decomposition. First part is precipitation, second part is neutralization. In the neutralization, we know acid plus base gives you salt and water, that is neutralization. But in this, we have two things. Titration also. Neutralization is one, titration is another one. Neutralization, when we can call it neutralization, if you are taking insoluble base, then it is neutralization. Titration, if you are taking soluble base or alkali, which you call. And I told you to remember four alkalis: NaOH, KOH, NH4OH. Okay, remember three here for this. So titration is what? When you take NaOH, KOH or NH4OH with acid. But if you're taking any other base, insoluble base, then that will be specifically called as neutralization. But sometimes what they do, they will give you NaCl. Okay, preparation of NaCl. So how you prepare? HCl plus NaOH. NaCl plus water. Since I am using NaOH, which is a soluble base or alkali, you call it as titration. But if they don't give you the option, specifically if they don't give you the option of titration, then you can match it with neutralization also. Okay, if they give you titration, then you match it with titration. Fine. Any doubts in this? This is very important. Okay, and whatever precipitation, not form precipitate, these points, this is very important. Okay, this will help you to write the precipitates reaction. Let's take some examples. Okay. Anhydrous iron 3 chloride. This question will repeat a lot of times, huh? FeCl3. Remember and fix it in your mind. It is direct combination. Yes. Fixed question. Okay. See, this is another kind of question they have asked previously. What they have asked here, match the column. They have given some salts with, from this you have to prepare this, and which method you will use to prepare that. Okay. See here, lead nitrate from lead oxide. Ha. See, first of all, understand. One second. Lead nitrate will not form a precipitate. I told you why I told you to remember this, because you should not match it with precipitation. All metal nitrates, they are soluble, correct? Therefore, what you do? Okay, it is not a precipitation, but PbO. PbO is what? It is a metallic oxide. Metallic oxides are what? They are bases. And what do we know for bases reaction? Neutralization or titration, है ना? So here PbO is a soluble or insoluble? Insoluble base. Why? Because I know soluble bases are NaOH, KOH, NH4OH. So PbO is insoluble base. Then it should be neutralization, not a titration, neutralization. Okay. How, sir? How we are getting that? See, PbO is a base, and from that you want to get lead nitrate. And if it is a neutralization reaction, what we should have, another reactant should be an acid. And which acid we have to take? Here it is nitrate you want to get, you have to take nitric acid. Correct? everything will be there only. So this is the equation for A. This is a neutralization reaction. Correct. MgCl2 from Mg. So whenever metal is there. Ah, yes. No, no, no.
Sorry, displacement.
Ah. Whenever active metal is there, except FeCl3, as I told you, you fix in your mind it is combination. First you can match that only. Okay, na? Then another active metal is there, then you want to get the salt of that. You will be have to match it with simple displacement always. So if they ask you write the equation for this, right? So Mg you have, and what do you want to get? MgCl2. So Cl2 where it will come from? From the acid HCl dilute. So you will get hydrogen gas, then balance it. Okay. FeCl3 combination NaNO3 from NaOH. Now you see. Yes, yes. So NaOH is a soluble base. Now you can match it with the titration. And what is left? Last one automatically precipitation. Carbonate is there. So carbonates of zinc, lead, I told you they are precipitate. So from zinc sulfate. Now see, zinc sulfate they have already given. If they ask you to write the equation for this, so zinc sulfate should be soluble then. है ना? Then you want to get zinc carbonate. So now you don't know which compound of carbonate is soluble.
Sodium carbonate or zinc
Yes,
carbonate.
yes. You can use ammonium, sodium, or potassium. Anything you can write it here. Carbonate. So just double displacement K2SO4. Okay. This is how you have to write the equations. For NaOH, you can write what? You want to get NaNO3 from NaOH, no? So you will use dilute nitric acid. Yes. Plus NaOH, NaNO3 plus H2. Okay. So this you can write without any mistake only if you know this part. Only if you know this part, which are precipitates and which are not. Otherwise, it might get confused. Again, similar kind of question here. You have to name the method. Just match the column kind of thing only here. Okay. So here A is sodium nitrate. This time they didn't give you from which. They directly given you which method you have to take. Okay. So A, B, C, D, E. So Ruhani, tell me for sodium nitrate, what you will use? First of all, okay, which option you already know that you match?
Iron 3 chloride.
Ha. Two?
To direct synthesis.
Yes. So first you people do that, whichever you know that you do. ठीक है ना? Okay, now you tell me sodium nitrate, what you will use?
Sodium nitrate.
All sodium and potassium compounds you want to prepare means usually it will be double decomposition.
Yeah.
So under that which one? Double
Can we
decomposition.
use
Here you have
double decomposition?
you have neutralization which also comes under double decomposition. Which one you will use?
Yeah, so neutralize.
Yes, neutralization you have to use. Okay, because the other one may be precipitation. Sometimes instead of giving you precipitation, they have given double decomposition. है ना? ठीक है. Dhruva, tell me the C, lead chloride. Lead chloride. Dhruva? Mm, mm, mm. Chloride of lead, lead chloride, lead sulfate, lead carbonate, they are all precipitates, isn't it?
Oh, yes.
Hmm. Okay, zinc sulfate should be simple displacement. And lastly, E, sodium hydrogen sulfate. This is from your
Zinc sulfate is, yeah.
first one, no? Simple displacement. Zinc plus sulfuric acid, है ना? Okay, lastly, what is left? Decomposition by acid, third. Okay, decomposition by acid. sodium hydrogen sulfate. Okay, give a suitable terms. This one, leave, process. Okay, these are old things. This one. A salt formed by incomplete neutralization of an acid by a base. Acid by a base. Chanvi, tell me.
Sir,
C.
complete neutralization by a base.
Hmm.
Sir,
Incomplete neutralization of an acid by a base.
sir, not sure.
Okay, I will give you option: acidic salt, normal salt, basic salt.
Oh, like that.
Hmm.
So then acidic, because it still has hydrogen.
Right. Okay. Acid salt or acidic salt. ठीक है. Given appropriate scientific reason, electrical conductivity of acetic acid. Okay, these kind of question have been asked many times. So here, see how what you have to write, even if it is for 1 mark. Whenever they give you two acids to compare, to write first dilute sulfuric acid is a strong acid. So strong acid के लिए what you will write, it will completely ionize in water. So when it completely ionizes in water, you will have more number of free ions, because you are conducting electrical conductivity we are comparing now. तो more number of free ions मतलब more will be electrical conductivity. Second one, acetic acid. It's a weak acid. Weak acid will partially ionize. These all points you have to write. So less number of ions, free ions. Therefore, its electrical conductivity will be less. Same thing they can ask you why. They will change the question. They may ask, the concentrated acetic acid is less acidic compared to dilute sulfuric acid. Then also you will write the same answer only. Okay, these are the key points you should not miss. And based on this balanced equations, action of heat on a mixture of copper and, okay, leave it. Action of warm water, okay, leave it. Magnesium sulfate solution is mixed with barium chloride solution. So this one is simple displacement, double displacement reaction. So reaction you can easily write barium sulfate. Barium sulfate will be white PPT, plus magnesium chloride, white PPT. State your observation. Moist starch powder paper is introduced to chlorine gas.
So blue,
Hmm.
some blue black.
Turns blue black. Okay. Okay. Give balanced equations. Again, these kind of questions have been asked. Lead sulfate from lead carbonate, sodium sulfate, dilute sulfuric acid, copper chloride. So here you can see lead sulfate from lead carbonate. Okay. Rn, what you will use here?
So for the first one or second one?
First one.
Lead sulfate from lead carbonate. H2SO4.
H2SO4, dilute.
Can we use it? Yeah, that.
Okay. What will be the products?
PbSO4, water, and CO2.
Right. Okay. Balancing, I think you can do. Okay. Second one, Tanisha, can you tell me how you will get NH2SO4 from H2SO4 dilute?
Um,
Which compound of sodium you will use?
um, 1 second. Okay, so
This is
what are you?
simple neutralization reaction. You have to use a
Yeah.
base which contains sodium.
Okay, NaOH.
Ah, that's it. NaOH. So you will get salt and water. Okay, balancing. Copper chloride using copper carbonate. Again, similar thing. You can use here dilute. Don't use NaCl. This is not a precipitation reaction. So dilute HCl, CO2 plus H2. I have not balanced them. No, because I know you will balance. Okay, this is fine. Huh. This is a question based on your pH sometimes, or simply weak acid, strong acid based on that. Solution A is a sodium hydroxide, B is a weak acid, C is dilute sulfuric acid. Which solution will? So when they give you solution A, solution B, solution C, that only you have to write as an answer. Don't write sodium hydroxide, weak acid, dilute sulfuric acid. You don't write that. Which solution? Matlab A, B or C. Okay. Vanishika, can you tell me which solution liberate sulfur dioxide from sodium sulfite? Vanishika. Okay. Ion is not there. Rohani. Rohani is done. Sorry. Rushi. Which solution liberates sulfur dioxide from sodium sulfite?
So, sulfuric acid.
Solution C, correct. Because it is a typical acid reaction. Typical acid reaction is what? Metal sulfite plus acid gives you salt, water and SO2 gas. है ना? Give a white precipitate with zinc sulfate solution. Yes, Dhruva, tell me. Zinc sulfate.
So, solution A.
Solution A, yes, sodium hydroxide. This is when analytical chemistry will learn. Zinc hydroxide will form, which is a gelatinous white PPT. Definitely the solute molecules or ions, that should be solution B. Give the equation. Okay, okay. Huh. Danish, can you tell me copper sulfate from copper 2 oxide? All of you can try yourself also. Danish. Okay, who else is there? Darshwana. You can try yourself also. Darshwana, can you tell me?
Yes, sir. CuO
Hmm.
plus uh, sulfate.
You want to get copper sulfate. Sulfate will come from where? CO is what?
H2S.
Ah. So you have to analyze. CO is a base. Then I will use an acid to get the salt and water. Okay. Iron 3 chloride is anyway combination. This you people don't forget. Potassium sulfate from potassium hydroxide. It is similar thing. KOH is a base.
Same.
K2SO4. So you have to use H2SO4 dilute plus H2O. Last one is two equations they have written. Okay, what is this? Lead chloride from lead carbonate. So lead carbonate, first one equation you have to do, then you have to convert it into lead chloride because they have mentioned here two equations. Okay, so what we will do? Hmm.
PBO. Uh,
No, 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 no. Lead carbonate you have to take.
but first you have to heat it, right?
Okay, if you heat, what will happen? PBO plus
PBO
CO2. Okay.
plus.
So now you will take PbO plus.
HCl dilute.
Very good. You can use this, no problem. Okay. Or you want to use some other reaction also, you can use for the first one. Like you can, if you add dilute nitric acid, you will get lead nitrate plus CO2 plus H2O. So lead nitrate you take, then you treat it with HCl dilute. Okay, or NaCl also. You will get lead chloride. Lead chloride is a precipitate, no? So you can do that. But I think better option will be that, because anyway this also works, no problem. But see, better option I'm telling you here, sometimes some teachers don't accept, no? Therefore
So
see,
when I do,
dilute nitric acid you take, make it soluble substance, because lead carbonate is insoluble in water. So lead nitrate we will make it plus CO2 plus H2O. Then that lead nitrate we will use. Then precipitation reaction, I will use NaCl aqueous, so PbCl2 plus NaNO3. Okay, this one we can use. Okay. Okay, these kind of questions have been also asked. Again, you have to see the arrow mark properly. Sometimes here they will give you the some here like here. Okay, you have to observe the arrow mark carefully. So here what you have to write, give the equations. So you understand here A is an equation. Okay. So A is what? ZnSO4, say ZnCO3 you have to get. Huh. So zinc carbonate is a precipitate. Therefore you can use Na2CO3 plus, because carbonate, sodium carbonate or potassium carbonate you can use. Then you will get zinc carbonate plus Na2SO4. So this is again how you, based on your knowledge of acid bases and salts reaction, based on that you have to work. Then take this zinc carbonate, from there you have to get zinc nitrate.
H-no-3 dilute.
Yes. So here how do you know? Nitrate you want to get precipitate. Nitrates are not precipitates, and zinc carbonate is also not soluble in water. So precipitation you should not write. Here you have to use acid, HNO3 dilute. So it will break this compound into zinc nitrate, CO2 plus
CO2
H2.
plus
Okay, this one only you can call as decomposition by acid. That option they gave you previous question, no? That. See, zinc nitrate say zinc hydroxide. Now zinc hydroxide is what? Precipitate. How do you know this? Because in your analytical chemistry all hydroxides only na precipitates. So from that knowledge also, because these are not individual questions, you, these are all mixed questions, no? So you have to use it. Yeah, here you can use NaOH.
so I can use NH4OH also, right?
NH4H also, yes, you can use, because both will give you the precipitate of zinc hydroxide and NaNO3. Lastly, zinc hydroxide is zinc oxide.
Heated.
Huh. So here you should not add anything. It is simply heating of metal hydroxides. You will get metal oxide plus water.
H2O.
This is your, again based on your knowledge only. Lastly, zinc oxide says zinc sulfate.
Plus SO2.
Zinc oxide says zinc sulfate. What you will add?
Plus SO2.
H2SO4 na.
Oh, yeah, no, man.
Huh. So base plus acid gives you salt and water. Zinc sulfate is a salt and H2 is a water. ठीक है ना? SO2 you can't use here, gas. चलो. This will not be as like this is a preparation of iron 3 chloride, so leave it. This is not coming now. This is a,
No, no, textbook also.
huh. This is the last question. Again, similar thing. Making use of substances given means these are the substances given. give the equations for the reaction by which you could obtain hydrogen, sulfur dioxide, carbon dioxide. Again, simply based on your knowledge of acids, reaction of acids and salts. So hydrogen, when you will get active metal plus,
plus
ah,
H2SO4.
yes, very good. Zinc plus acid, like that is dilute sulfuric acid. So that reaction you have to write. And what you should not forget is here dilute. Everything you write, dilute you don't write, then you will say, sir, I did silly mistakes. Hmm? B. Sulfur dioxide.
Zinc plus sodium sulfate.
Zinc, why you will use? Again, you have to use acid only, na? Acid plus metal sulfite, है ना?
Oh yeah. Yeah.
हाँ. So
Yeah,
sodium
but
sulfite.
zinc is amphoteric, right?
Okay, what you will write? Na2SO3 plus zinc. What you will write here? Tell me.
Uh, oh yeah, there should be another H.
What you will get here? Okay, this is a typical acid reaction. Metal sulfide plus acid dilute sulfuric acid. So you will get salt, Na2SO4, water, and SO2. Yes. Carbon dioxide. And here, see, they didn't mention that you have to use it only once. No, nothing like that. You can use multiple times. So carbon dioxide you want to get. So you have to
Sulfuric
use.
acid.
Huh?
Sulfuric acid plus calcium carbonate.
Huh. Why can't we use sodium carbonate?
So it will not repeat.
It will not give you CO2. It will give you. It will give you. Okay.
Yeah.
Huh. Okay, that also we can use. But sodium carbonate, let's say, or calcium carbonate also you can use. Again, dilute sulfuric acid. Sodium sulfate.
So I think we should use sodium because they can more easily replace the hydrogen than calcium.
That we can say because calcium carbonate is a kind of precipitate and it will not dissolve also. It will take more time. Yes, that can be done. And D, zinc carbonate, two steps required. Again, based on whatever available. So zinc carbonate you want to get means first of all you have to select zinc, right? Then treat it with
Yeah, zinc
something.
plus H2SO4.
Okay, what you will get?
7SO4 plus
That
H2SO4.
is the right first one only. Okay,
Then
next.
that plus
Hmm.
H2CO3.
But H2CO3 is not given here.
Oh, then sodium carbonate.
This time you have to use sodium carbonate only, not calcium carbonate, because calcium carbonate is a precipitate. It is not soluble in water, but you have to take a soluble substance of carbonate, which because whatever you're getting zinc carbonate, it's a precipitate. Therefore, your starting material should be soluble. Okay, ZnNA2SO4. So you have to use sodium carbonate here. Okay, fine. So this is your last slide. If there are any doubts, anything, let me know. We can discuss that.